Hello and welcome to CodeSlicing. This is part 2 of an exciting 2-part series where we are recreating a busy screen. But we all know that's not the really exciting part, which is the custom timing curve utility that we're building. Now it feels like we did loads in the first episode, but we're only halfway. We've got a grid with the points in the wrong place, we can't move them about, we're not generating any custom timing curve animations, and it basically is a bit unfinished. We're going to address all of that in this episode, but if you did miss all of that, do go back and check it out to bring yourself up to speed. For those of you who are ready to continue, let's do that. Right, so we finished off the last episode talking about coordinate spaces and how we were going to define our own coordinate space to make this very easy indeed. So let me define that now and it will hopefully become clear. What we're going to do is this Z stack itself, this Z stack is going to define our coordinate system, okay? Which means that we can work within it without worrying about where that grid is itself. I'm going to actually specify a name constant for this called private let grid coord name is grid coord. Right, so we say coordinate space and we pass in our grid coordinate name, like that. Now we have our coordinate space. So any coordinates we're talking about are going to be within that grid. So now we can use our offset to position modifier like this. We say offset to position. All right, we pass it in the position we're interested in, which is the mapped point, right? CP0 mapped. And then we say in, and we give it our grid coordinate name. And we're going to do the same for CP1. Now, if I resume that, look at that, it's worked. So they are now exactly where they should be, right? If I move these around, well, let me do that and resume. Perfect. All right, so we've got them doing what we want them to do. We're not moving them yet, but that comes in just a second. So the next part of this is to put a drag gesture on these things, which is going to allow us to move them about. And that again is very easy, and it's really easy because of this coordinate system we're using. There's so much boilerplate you don't have to worry about when you use bespoke coordinate systems. It's really not funny, but in fact it is funny. Makes you laugh. So what we're going to do is we're going to say, here's a gesture. We give it a drag gesture. And in that drag gesture, we say the coordinate space is a named coordinate space with our grid coordinate name. And then we say onChanged, which is our gesture value. And then we assign the location to CP0. All we would do if we didn't need to map it. Now bear in mind, the value that we're going to be getting back from this is going to be somewhere between 0 and 200. Those are the min-max values for this grid. So we need to translate that back to a control point that a timing curve understands, which means we have to do the reverse of what we did before. So let's put another function in. So we're going to say our private func map to unit point, which takes in a point, which is a CG point, and we're going to go from size, CG float, and that returns a CG point. We say let scaled point equals point scaled 1 over the size, because we're dividing by the size. But now we've got a unit point that has an inverted Y, so we need to invert that back. So we say return invert Y on the scaled point. All right, so now we can map it correctly and we can say map to unit point and we pass that in and then we say from geo.width. And we could have said height, they're the same thing because it is a square. Okay, terrific. Now we need to do the same thing for CP1. So let's duplicate that and move it down. And we're going to be setting CP1. Now, what we're going to do in this case because I don't want to bother with the checkbox that says move them both symmetrically, but will allow you to do it if you want to, is that if you pick control point 1, I want that to move symmetrically with control point 0. All right, so we'll say self CP0 equals a CG point, and we'll say 1 minus self CP1 dot X and 1 minus self CP1 dot Y. And now if we resume this, I think this is going to work. Oh, yes. Perfect. That's exactly what we want. Right, so now we're going to add some animations and some points that are going to represent the timing curve that we are actually creating here. Before I do that, let's actually put in the text, which is going to show us what our control point values are. And to do that, I'm going to create a little function here that is going to return us a text. You know, just makes things easier to keep the formatting in one place like this. There are probably about a million ways you could do this, but I'm doing it as follows. Text for point. We pass it in a control point, or pass it in a point, and we'll pass it in a name. And that's going to return us a text component. And that's going to be, we're basically going to format these points so they've got 2 decimal places. We don't want all those decimal places that we are not interested in. And we're going to give that a headline font like that. And then we're going to use it up here. So instead of a Z stack here, I'm going to return a V stack. And I'm going to put it around there. And underneath that, I'm going to say text for point and say self CP0, which is going to be called CP0 and CP1. Now, if I resume, we should see the values. Okay, but they're coming out as black. So let's fix that and we'll just put white in here. Right, there we go. So let's think about what we want to do. We want the points to go from the left side of the screen to the right side of the screen. And we don't want them to be visible when they're off the screen. So that means we need to offset by half the width of the screen plus the size of the points. So let's define the size of the points first. So private let dot size is 8. Then we're going to say that the max offset is going to be equal to the UI screen main width scaled by 0.5, and we're going to add the dot size. We're going to say that we're going to have a V stack. So we're going to have our dots above our view. All right. So we need to have it at the bottom of a V stack like that. Now we also want a title on this, which will say in look of 80 points, and it's going to be white. And now we need to put in our dots, which we'll put in a Z stack because we want them to all start at the same place, right in the center, and we want to offset the X for the animation. So how many dots are we going to have? We'll say private let num dots is 5. Right, sorry about that. Managed to crash Xcode. Life in the fast lane, eh? So where were we? We want to define these points. So let's do that here. We've got a Z stack and we're going to loop over those points. Nice and easy. Num dots index in. They're going to be circles with a fill color of white. and a frame of dot size. Right, if we resume that, we should see our dots all piled on top of each other. There they are.
Hello, this is Adam from the future here, but your past. You'll notice on line 16, a variable has appeared as if by magic. Well, after the crash, I didn't actually rewind far enough to get back to the state before it crashed. So let me just briefly explain that now. The reason I've got an array of animating booleans is because we need to control the animation explicitly for each dot. We can't just have a global animating variable that says whether or not we are animating, because we need a delay between the dots. But that isn't as simple as just applying a delay to a forever animation, for example. Delays on animations are cumulative, so it will get out of step after even just one iteration. And the second problem is that we need to explicitly control our animations because we want to be able to update them in real time and see what difference the changes to our control points actually make. When we are using onAppear to start our animations, which we will be doing in just a minute, that only runs when our view is shown. So we can't update the animations once they are set. So that is why I've got this array of animating booleans, and it is also why we're going to be driving our animations explicitly, as you will see very shortly. I do apologize for the interruption. Please continue.
So the next thing we need to do is do the offset. So let's do the offset now. X offset, animating index. Is this dot animating yet? If so, we want it to go all the way over to the other side. If not, we want it to be all the way over to the left. And then we say in our onAppear, we are going to completely control this animation. We want it to be repeating, but we don't want to use a repeating forever animation. And we do that like this. We'll start off with a delay like this, after index times 0.2. That's our delay taken care of. And now we want to run something every duration. So let's stick in a duration up here. Private let duration, which is a double, equal 2. And then we want to say every duration. And this is important. We want to say that the animation is false outside of an animation block. So every iteration, the first thing we do is we set the animating value for that dot to be false outside the animating block so we don't see it moving. Self animating index equals false. And then inside an animation block, we'll just use in-out for now. With that duration, we don't need a repeat forever or anything like that. This is going to take care of that. And we say self animating index equals true. Now let's resume, see what happens. See, I think we're going to get a nice ease in out animation for all these dots going across the screen. Wonderful. That is exactly what we want. So now what we need to do is take our custom timing curve and allow it to generate our custom timing curve, right? So we can actually use this as a utility, right? We'll say func generate, give it a duration, which is going to be a double with a default of 0.35, which is the system default for animations. We say animation. And then we want to say animation, cool, animation, say that a number of times. Timing curve. This is what it all comes down to, folks. CP0.x, CP0.y, CP1.x, CP1.y. They all need to be doubles. So let's do that as double. And then we'll say duration is duration. that's enough. That is enough to generate our custom timing curve. So all we need to do now is say custom timing curve, generate, and resume. And if we've done it right, we should see a linear animation. And there it is. Shall we try to move the points? It is working. And if we want a symmetrical animation, we can do that. And that's pretty much where we want to be to recreate that waiting screen that we all know and love. And there you are. So now you have a utility you can use in any project. If you've got a custom animation on your hands, you can just drop this in, have a look at the curve, and then change the curve until the animation looks just right. Take the numbers, plug them into your custom timing animation. It really is a lovely way to work. If you enjoyed this content, drop a like and consider subscribing for more. If you have any comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.